All right, here we want to solve exponential equations. To do that, we need to remember a little bit of things about exponents. So here we've got, just in general, one of our properties as well as some of our what we call laws of exponents. Just in case we had forgotten, it's been a long time probably since we did some exponents. So one thing to remember that will be really important is that when two exponential expressions have the same base, their exponents are also equal. Okay, so if you notice up here, it says if AU equals AV, then U equals V. So basically what we're saying is that if the bases are the same, I'm going to cancel them out and I'd have just the exponents left over. Okay, that's kind of that property. Then we have these laws of exponents, which are just to remind us how we can deal with exponents if we need to. So this first one here is saying that if I multiply and I have the same base, I'm adding the exponent. So multiplication of the same base turns into addition. Okay. If I have one base and I have an exponent to another exponent, then I'm going to be multiplying. Think of it as I'm distributing into that parenthesis there. Okay, so that's when I would multiply their exponents. Okay, again with that same idea of distribution, if I have more than one thing inside parentheses, that exponent is going to get distributed to each of the values inside the parentheses. So that means the A would get the exponent and so would the B, right? Our next property, hopefully we remember this in general, 1 to any power is still 1. Okay. Our next property is what we call a negative exponent property. A negative exponent property means that if I have any exponent that is negative, I could rewrite it as a fraction, meaning that this negative is going to become positive when it moves to the denominator of a fraction. Okay, so if you kind of think of this as saying A divided by 1, I can kind of think about it as that a negative is going to flip that fraction. Okay, so instead of A over 1, we get 1 over A. Okay, the last one is a reminder that any number, letter, whatever the case may be, anything raised to the 0 power is 1. So those are kind of the properties just that we need to refresh, remember, those kind of things. So in case we see those kind of pop up as we are solving. Okay. Now to actually solve, we've kind of broken it into two kind of scenarios here. One scenario is that I have only one exponent. Okay, when I'm talking about exponent, I'm talking about the variable is in the exponent, okay? And then the other case is if I have two exponents, meaning I have a variable in two different exponents. Okay, they're going to get solved completely differently. So I'm going to look at each of those separate as we get into the examples. Okay, if I have only one exponent, the first thing I'm going to do is I'm going to isolate the exponent. I'm going to use this change of base formula, which I'll show you as we do the examples, and then I'm going to continue to solve. If I have two exponents, then what I'm going to do is I'm going to make sure that those exponents are on different sides of the equation or different sides of the equal sign. And remember we said that the same bases cancel. So the goal is to get those bases the same using maybe some of those properties of exponents. Then I can cancel them and continue to solve. All right, so again, it seems a little bit far out there right now because we're just talking about it. So let's actually do some and see if we can get it. Making a negative. Okay, so we're going to look at the first scenario that I discussed when we have only one exponent. So I noticed that even though we have lots of numbers, there's only one variable in an exponent. So what we want to do is we want to isolate that variable or isolate that kind of exponent there. We want to change the base to be a base that is the same and then we want to solve it. So let's look what that looks like in a problem, okay? So looking at this first problem, I want to isolate that 3 to the x plus 1. So to do that, what I'm going to need to do is I'm going to need to move that 2 to the other side. So let's go ahead and add that 2 to the other side. Okay. So I have 3 to the x plus 1 equals 9. So now I've isolated that exponent. Okay. So the next step that I want to take is I want to change the bases to be the same. So what that means is I'm going to actually look at the smaller of the two. So I'm going to look at this 3 here. I'm going to say, okay, how can I make, using exponents, a 9 become a 3? Well, 9 is really 3 squared, right? So, and I notice that base of 3 is now the same. So I want to change this 9 into 3 squared. Okay, that's what I mean by we're going to change the base. Now remember that property on that first slide that said if I have the bases the same, I can cancel them and I'll let their exponents be equal. So now what I really have is x plus 1 equals 2. All right, so finish solving it. X plus 1 equals 2. That must mean that x is going to equal 1. All right. So let's see if we can kind of follow those steps as we do our next ones here. I want to isolate my exponent. To do that, I'm going to need to move that 3. And you might be thinking, well, I wonder why they put parentheses around that. They typically put parentheses around it if it's either a fraction or there's a number multiplied in front, okay? That's kind of why they do that. All right, so now let's look at this. I've got a 1/2 and I've got a 4. So I need to change my bases to be exactly the same. So I got to remember those exponent properties. So remember we had an exponent that said, if I have a fraction here, I could flip that fraction, making this 2/1, which is the same as 2. Therefore, I'd have a base of 2. To be able to do that, I need to use a negative exponent. Remember, that was one of our properties, have a negative exponent. So let's go ahead and do that. I'm going to make this 2 with a -1 to x minus 4. Now, the reason I want to do that is because isn't 4 the same as saying 2 squared? So now I can say, well, that's just 2 squared. I notice that I have the same bases. Once I get the same bases, I'm going to cancel them off and I'm going to solve. So I have this -1 with my x minus 4 here equals 2. So I'm going to distribute. So I have a -x plus 4 equals 2. Keep solving it here. So x is going to equal 2. All right. So remember I said you're going to really have to remember those exponent properties. When I go to change the base here, that's where I'm going to need all of those exponent properties that are on that first slide. Okay. So let's look at this last one here. I'm going to isolate my exponent here. So that means I'm going to need to get rid of the 2. So I'm going to divide it by 2. So I'm going to have 4 to the x plus 5 equals 16. All right. So I look at these and I say, how can I get these bases the same? Well, 16 is really just 4 squared. So I can leave this 4 to the x plus 5 alone, but I'm going to change this to be 4 squared. So now I can cancel off those bases, x plus 5 equals 2, and solve it So x is going to equal negative 3. All right? So really the isolating, not difficult. The solving, not difficult. It's going to be that change of base. Getting those bases to be the same because I really have to remember and utilize a lot of different exponent properties. Okay? All right, so this one's similar. It's just going to look a little bit different because I start off and I have two exponents. So I have exponents need to be on both sides. Most of the time it'll already be set up like that, but if it's not, I need to make sure that I have both of my variables on either side of the equation, okay? Once I do that, I'm going to get the bases the same. That's going to be just like what we were looking at last time. That's where I'm going to use those exponent properties. Okay. Then after I do that, I'm going to cancel off those bases just like we did last time, and I'm going to solve it. The solving this time is going to be a little bit more, not necessarily intensive, but it's going to be a little bit more involved because I'm going to have variables on both sides. But it'll be just as easy as solving a regular equation. All right, so let's look at what this is going to be. There's no such thing as isolating anymore. I just want to make sure that they're on both sides. So typically this is just kind of like, oh, check it off my list. They're on both sides. Okay. So this one is already on both sides. So what I want to do is I want to get the base of a 4 and a 16 to be exactly the same. The way I'm going to do that, I can turn 16 into 4 squared. Okay. So I'm going to leave my 4, x plus 3 alone. I'm going to turn 16 into 4 squared. Now that the bases are the same, I'm going to cancel off the bases. So I get x plus 3 equals 2 times x minus 1. Okay, so this is what I meant. The solving is going to be a little bit more intensive here. So I'm going to need to distribute. And then I'm going to get my variables on the same side. Continue to solve it here. So x is going to equal 5. Again, just like last time, the hardest part is getting those bases the same. Remembering those exponent properties. Okay. So, on our next problem, I've got my exponents on both sides. Perfect. So I need to get 5 and 125 to be the same. 125 is 5 cubed. So I'm going to leave my 5 where it is. I'm going to turn 125 to 5 cubed. All right. My bases are going to cancel, which is going to leave me with x squared plus 8 equals 3 times 2x. So I've got x squared plus 8 equals 6x. This is a quadratic, so I need to set it equal to 0 to solve it. So I'm going to move that 6x to the other side. Then I'm going to go ahead and factor this to be x minus 4, x minus 2, setting each factor equal to 0 gives me x to be 4 and x to equal 2. All right, so again, it's that solving is a little bit more intense, and the difficulty level still comes in getting those exponents, or excuse me, those bases to be exactly the same. All right, let's look at our last one here. Okay, so I look at my 9 and my 27 and say, okay, how can I get them the same? Well, 27 is not 9 to any power, so that means they both have to go down, meaning that 9 is 3 squared and 27 is 3 cubed. So it's not enough sometimes, like in the last two examples, we only had to change one side. But sometimes I'm going to have to look at both of the sides and change them down. So really, I need to change this first one to a 3 squared. And then my second side to a 3 cubed, so that those bases will be the same. Now that the bases are the same, I'm going to cancel the bases. So I have 2 times a negative x plus 15 equals 3 times x. I'm going to distribute here, negative 2x plus 30 equals 3x. I'm going to finish solving it here, get my 2x to the other side, divide it here. So x is going to equal 6, right? So we've got those two cases, one where I've got exponents on both sides, which is what we just looked at. I've got to get the bases the same, cancel them off. Sometimes that means changing one side of the equation. Sometimes that means changing both sides of the equation. But each time I'm using exponent properties to do that. And then in our other case we had where we only had one exponent, we're going to isolate that exponent. Again, we have to get the bases the same by using those exponent properties. And then we're going to cancel it off and solve.